This video will show you how to do problem number 48 in chapter 4's homework in the textbook. The amount of sunlight that a location has per day is of interest in the use of solar power for creating electricity. The data set has the amount of sunlight hours in Finland in a year. So we have the date, we have the day, because it's really hard to put dates and such into spreadsheets. So I converted it over to days, and then the length of daylights. We'd like to use technology to create a scatter plot for the data. We're going to use a TI-83. The first thing I'm going to do is going to go into the stat button, STAT button. I'm going to go into edit, and I'm going to go into number 1, edit. If there's something in your L1, you'd like to clear it out. To clear it out, you go up onto the name L1, hit the clear button and hit enter, and it gets rid of whatever's there. Move over to L2, do the exact same thing, clear and hit enter. You then need to type in the data. We want to put the days in L1. We want to put the length in L2. I've actually already put these into mine. You haven't done that to yours, so you can now start typing them in. I will get mine where they need to go and get my data in. So at this point in time, you should probably go ahead and get yours put into there and type your data in. So again, the day goes in L1, the length goes in L2. So you should now have all your data in to your calculator. So now once you have your data into your calculator, the first thing you might want to also do is hit y equal to, because we want to plot this data up and you want to make sure there's nothing in y1 or any of the y's. If there is, clear it out. Now this top row is everything that has to do with graphing. So you can hit the second button and the y equal to get into the stat plot. Since we use the stat menu, we're going to use the stat plot. You're going to go into plot number 1. You want to turn it on if it's not already on. You want to pick the scatter plot. Your list 1 should say L1, and your Y list should say L2, because that's where you put your data. The mark and the color are up to you. Now what you want to do is go into the zoom button. Number 9 says zoom stat, which means it will fit the window based on what your data is. So you can either press number 9 or arrow down to the number 9 and hit enter. When I do that, I get a nice looking graph that looks like it goes up and then comes back down and then kind of looks like it's leveling off here a little bit. So it kind of looks like a quadratic equation or parabola. Kind of does, because it has that up and back down shape to it. However, we got to think about what this is. This is the amount of sunlight on a year. If I took another year, I'd get the exact same graph. If I took another year, I'd get the exact same graph. Every year would have the exact same graph. It would go up, come down, and then go up and come down, and go back up and come back down over and over and over again. So this is actually what we call periodic, because in reality, the data is repeating itself over and over again. So that's what we would use. And now if you want, you can take a picture of this and put it in your homework or whatever you want to do to create it. The next thing we want to do is use technology to create an appropriate model. The model looks like it might be periodic. So again, I'm going to go into the stat menu. I'm going to move over to the word calculate this time. And we have LINREG, that means linear regression. QUAD means quadratic regression, and so forth, all the way down. And we've got a lot of different choices here. This one is periodic. And when I go down, I find this one that says sine regression. If I go into the chapter at the start of modeling, I will see where it talks about, let's get to this topic. It talks about periodic, and it talks about this sine graph. So we need to use this sine regression. We'll hit enter. The iterations, leave it at 3. We'll just do the default of what it does. The X list is where you put the data. It's L1 is where you put your X's. And then your L2 is, went too far down, trying to get back to our data. Our L2 should be your Y list. So we have that information, period. Don't worry about that. Leave that as alone. And then we want to do the store. We want to tell it where to store the data, the equation, because we want to be able to use that equation. I want to store it into Y equals. Those are variables. So if I hit the vars button, which means variables, and I move over to Y variables, because I'm going to put in the Y equals, and then I'm using functions. So I pick number 1 for functions. I have a bunch of different choices. It doesn't matter which one you pick. We might as well do the first one, Y1. What this will do is when it calculates the equation, the model, it'll put it in there for us. We then go down to calculate and we hit enter. It then calculates that for us. It gives us all of our parameters. The A, the B, the C, and the D are all parameters. They're all numbers that we have to kind of calculate. And there's our model. You can now write this model down. Y equals A is 6.34, let's say. Sine of B is 0.17 times X plus C. C is, it should be plus, but because C is a minus, we're going to do minus 1.33 because plus a negative is just that. Close that parenthesis and then plus your G, which is 12.2. So there's my model that models this data. It would like us to determine the R squared value for it. Unfortunately, the TID3 calculator does not calculate an R squared value for sine regression. So we won't be able to do that here. Desmos does do it for you. You're then going to use your model to estimate the length of the daylight hours 160 days into the year. Notice I don't have 160 days here. 160 days falls in these values. There's 151 and 181. 160 lives somewhere between those two numbers, but I don't actually have that value. But I can use the model I just came up with to find that value. Let's go ahead. If I hit Y equal, you'll see there's my equation that I just came up with. It just put it in there for me. If I hit graph, it will now model that data, put that graph, that equation function modeled with the data we have. So you can see it's quite nicely done. If I'd like to calculate for 160 days, I'm going to hit the second button and the calculate. That lets me calculate certain values. Number 1 is a value. I'd like to calculate the value when it's 160. So I type in 160, hit enter, and nicely it shows you where it is and it tells you what that value is. So it says it's 18.4 or 18.5. So I can now type that that's 18.5. And looking at my data, that's hours. So don't forget your units. It wants to know if the value should be trusted. Well, it is in the original data. I actually have that 120 and 151 and 181. 160 lives somewhere in here. In fact, if I look at this, 151 is 18.35. 181 is 18.78, and we came up with 18.5. So it looks like it's right in line with what the data says. It looks like there's no reason we shouldn't be able to trust it. It actually falls right on my graph. It looks like it's just fine. So yes, we should trust it.